Hello, in this lesson we are going to see the triple scalar product and continue work on some applications on work. So triple scalar product is we have the A cross product with B, we have a vector, then we times another vector C, it will give us a dot product of two vectors, then it is a scalar. So this is what we are going to do for today. And it does have applications. So one application we know is not triple product, but it's a cross product. We have the area. And we know the area cross product, it will give you another one is on the either inside the page or outside of the page. Then we times with another scalar. If that scalar is kind of like the height, then we have the volume. So the triple product could give us a volume. So that is an application. And in addition to other application, triple product is could be used if they are coplanar. It means in the same plane, 2 dimension. If it's in 2 dimension, it will be because once this cross product will be either go inside the page or outside of the page. If we have another vector that is in this plane, then it will be 90 degrees perpendicular. Then if the triple product equals 0, then the 3 vectors will be in the same plane. It will form a 2 dimension. So these are the 3 applications for the triple scalar product. So now we are going to see the example. So we have done the similar questions before. Find the area of a triangle. So we just randomly draw a triangle here, PQR. So PQR is not in scale. It's just so in order to find the area, we could just from one point to decide 2 vectors. Then the U cross V give us a area of and 1/2 give us a base times height. 1/2 B times H, the area of the triangle. So question A, what we want to find is a PQ, that is one vector, and PR another vector. We know that is OQ second letter, then minus the first letter with the origin. So this is OR minus OP. So OQ is just this point. So it's 9, -1, -6, minus P, 7, 2, -5. So integer adding, subtracting, just x with x, y with y, z with z. So 9 minus 7 is 2, -1 minus 2, -3, -6 minus -5 is +5. So -6 plus 5, -1. And do the same thing to OR minus OP. So 7, 3, -3 minus P, 7, 2, -5. So make sure one of the point, the P, same. Okay, from the same point. Then get 0, 1, and 2. Then we are going to find the area. This time, remember, it's 1/2, not parallelogram. So it's PQ times PR. It doesn't matter which one is front, okay? And PQ times cross times PR, we are going to use the IJK, the matrices. So IJK is just direction. And the PQ is 2, -3, -1, align X, Y, Z direction properly. Then we are going to have, for the I direction is just this part, -3. So it's going to be just times -3 times 2, then minus 1 times -1. So -6 plus 1 is -5. Then plus J direction. For the J direction, we want to add another column, okay, IJK at the end, 2, 0. So this one will be cross times. -1 times 0 is 0, minus 2 times 2 is -4. Then plus K direction. K direction will be, get rid of K, we have these 2 times. 2 times 1 minus 0 times -3 give us just 2. So this is our cross product vector form. Then we are going to find the magnitude of that. So area of the triangle equals 1 over 2 square root x squared, y squared, z squared add together. So -5 squared plus -4 squared plus 2 squared. Then give us 1 over 2 square root 45. Approximately 3.50. So the first one is done. The area of the triangle is 3.50 units squared. Then it asks you to find the volume of parallel piped with 3 sides of it are OP, OQ, and OR. So what it means is we have OP, we have OR, then we have another one is vertical is Q, OQ. So it means on the base we have, this is another one, we could write P, so we have O, PTR as a base. Then vertically we go up, OQ. So all this one go up, OQ. Then we have a parallel piped. So this is this direction. So base is formed by OP, OR as 2 sides of the parallelogram. Then OQ is vertical, another dimension, 3 dimensions. So what we are going to do is the volume will give us, so this one, question B, the volume equals the 3 OQ dot product with other 2 cross product. So this is what we are going to do. Okay. So this is not related to the triangle, it's different. So from here we are going to see, first thing we need to find OP cross product with OR. So we draw the matrices IJK. Then P is just the original point P, 7, 2, -5, and R is 7, 3, -3, and the order doesn't matter. You could change this one to other order. You could write OP dot OQ cross OR. So it doesn't matter you treat which one is a base, as long as it's 3 of them dot product times cross product, they give you the same volume. So the order doesn't matter. You also could write OR at front, then dot product with OQ, OP. So they will give you the same answer for magnitude because the volume doesn't change. Then we do the cross multiplying. So for the I direction, it's this times minus this subtract. So we are going to have I direction 2 times -3 minus 3 times -5 is -6 plus 15 is +9. So this one will be +9 for I direction, then plus J direction. J direction, I just copy the I here again, then it will be just continue. -5 times 7 minus -3 times 7, we are going to have -35 plus 21, -14. Then for the Z K direction is just cross the K out. Is this 2 by 2 left, so 7 times 3 minus 7 times 2 give you 7. So this is OPOR cross product. Then we are going to write here. So magnitude OQ is just the Q XYZ coordinate dot product with this one 9, -14, 7. So just x times x, y times y, z times z give us 81. -1 times -14 is +14. -6 times 7 is -42. Then we only need the positive numbers, so it will give us 53. So now we know the volume is 53. We don't have the units. You could write units cubed. And the area of the triangle PQR is 3.5 units squared. Okay, so from this example, you will see if we have the XYZ coordinate of the triangle or 3-dimension figures, it's very easy for us to find the volume or area by using the dot product and the cross product. So, and we are going to see the next example about the work. So next part is do the work again. Work has very important application in physics, so we are going to revisit work again. So this one is just the force act on an object and move it along the force direction. The force times displacement give us a work. So we have done it many times. And this one, if we write it in magnitude, is F magnitude times displacement magnitude, and for the work is along the direction of the displacement. So this is adjacent, so it's cosine. And the dot product is cosine, cross product is a sine. We want a vertical. So work is a scalar. Now we are going to see find the amount of work done by F. So we are going to write it as a graph. So given is a force magnitude that is scalar and is moving an object from A to B. So this is a vector A, OA. We could write it as a -2, 1. OB is 2-dimension, is 7, 8. The force applied angle to AB at point A is, so this is A, this is B, and this is a force. The angle formed at point A is 30 degrees. So angle equals 30 degrees. And the required to find is the work, find the amount of work. and the units is in meters for distance. So analysis is a work. Formula is F dot delta D, then times, because angle given, the magnitude given, we want to use this magnitude times cosine theta. And we need to find the magnitude of delta D. So it is not given, so we want to find the delta D. Delta D is from A to B. So from A to B, then from A to B, then we are going to continue. Delta D equals from A to B is OB, second letter minus the first letter with O. So 7, 8 minus negative 2, 1. X minus X, Y minus Y give us 9 and 7. So the magnitude will be square root. 2 dimension is just x squared plus y squared. If 3 dimension, then it will be x squared plus y squared plus z squared. So this one give us 130. Then the work we could write is W equals, subbing all the given information, 5 times square root 130, then times cosine 30 degrees. Then it is approximately 49.37 joules. So we just write a statement. Therefore, the work done is 49.37 joules. So, and in science, the science teacher will say this is not right because we didn't focus on the significant digit, those type of stuff. So we just assume all of them, they are constant, they are exact value. So most of the time you could just keep 2 decimal places. So that is all for today's lesson. Okay. And what we have covered today is mainly on the triple scalar product. So it's a dot product and cross product times together give you scalar. The application is, first thing, if the dot product with the cross product equals 0, the 3 vectors are in the same planes to form the 2 dimension. And the area of parallelogram is just a cross product magnitude, and the volume is just dot product, then times 2 vectors cross product, then it will form the volume. And these 3 vectors is just, you have B here, C here, then the A will be not on the same plane, it's A here. So BC formed a parallelogram like a base, then all of them just raised A direction, then it form a 3 dimension. So these 3 vectors formed a 3 dimension figure. And this 3 per triple scalar product gave you the volume of this. So we use this formula to find out, okay, if it's the points given, then we just use 2 points, the vector on the 2 points, just the second point minus the first point. Then the cross product, we use a matrix. So if we want to find I direction cross I out, it's just 2 by 2 matrix left. We find the magnitude of this one. Then after we find the cross product, we find the magnitude. This is volume. Then from the cross product, we times another vector. Dot product give us a scalar. We only need the positive value, so we put absolute value sign to find the magnitude. That is volume. Then we go back to do the work again. So it's cosine theta. Then we find the work. Thanks for watching.